हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है।
So this is a complete design. Now understand that in case if yield stress is given, then how do you solve? The question given is like this. Design a Cotter joint for a load of say 25 kilonewton. The yield stress of material is 240 Newton per mm square. Take suitable factor of safety. Now if this is the question given to you, then load is known to you. There is no need to find the material because already the material is given and the yield stress of the material is given. The yield stress of material is given. But then they have written select suitable factor of safety. So how will we solve this? So first I will write, let us take or consider factor of safety of 3 for socket and spigot, and factor of safety of 1.5 or 2 for Cotter. Now understand that we are taking factor of safety of 3 for socket and spigot and 1.5 or 2 for Cotter, means we are taking less factor of safety for Cotter. What does this means? If you are taking less factor of safety for Cotter, means what does it means? It means that we are making this as a weak part. We are making or designing the Cotter as a weak part. We are taking less factor of safety. Less factor of safety means the strength of this part will be less, the dimensions will be less, and the strength of the part will be less. Weak part. Which part is weak? Cotter. And what about socket and spigot? See, socket collar, spigot collar, and rod. All of these are made up of same material. Okay. Cotter is also made up of same material. But what are we doing? We are ensuring that this should not fail. If at all anything fails, then it should be what? It should be Cotter. So we are designing Cotter as a weak part because we want that socket and spigot should not fail. What should fail is only Cotter should fail, because Cotter is a part which can be easily replaced. It can be easily manufactured and it can be easily replaced. I told you how a socket and spigot is manufactured, and I told you how a Cotter is manufactured. Cotter is just a taper waist shape part, so it's easy to manufacture and we can easily assemble it. It's just a matter of removing the old Cotter and putting a new Cotter. But if a socket or spigot has to be replaced, then the socket or spigot is connected to some other part. Then it is difficult to replace that failed socket or spigot as compared to Cotter. So we always design Cotter as the weaker part. Cotter as the weaker part. And for that purpose, we are taking less value of factor of safety for Cotter. Permissible stress for socket and spigot. And here I will write permissible stress for Cotter. So first I will write sigma t, that is equal to 240 divided by 3. You will get the value. Tau equal to 240 divided by 2 into 3. You will get the value. And sigma c is equal to 240 divided by 3 into 1.8. Similarly, for quarter, how will you write? Sigma t equal to 240 divided by 1.5. We will get the value tau equal to 240. Okay, this is 1.5. I think this is okay. Internet issue. This is 1.5 and this is into 1.8. No, let me explain you. Sigma t is 240 by 3. This is clear to you, no doubt. Sigma t is 240 by 1.5 for quarter. This is not needed. Not needed. Why? Because quarter does not fails in tension. So this value will not be needed anywhere. Then the second value is tau. Tau is shear stress. Shear stress is taken as half of the tensile stress. So tensile stress ka half. Tensile stress ka half is shear stress. So I have written it 240 divided by 2 into 1.5 here and then 3 here. And sigma c is crushing stress. Now this crushing stress value is taken as 1.2 times to 1.8 times of sigma t. 1.2 to 1.8 times of sigma t. So we have an empirical relation where we take it as 1.2 to 1.8. Now the question arises, in case where socket and spigot and Cotter both are in combination, which value of sigma will be used? Sorry, which value of tau will be used? Will we use this value of tau or will we use this value of tau? So in failure of Cotter in shear, that is this 8 number formula. Here we will use tau. Which tau we will use? We will use tau for Cotter. So I am writing it here for your reference. Here we will use tau for Cotter. See, tau for Cotter and tau for socket and spigot is different. So here we will use tau for Cotter. Is there any other place where will we use tau for Cotter? Okay, so let me conclude here for this. We will not use this value of sigma t in any case because Cotter is not going to fail in any case. Then we have this value of tau for Cotter, and where will we use this value of tau for Cotter? Tau for Cotter will be used only in one place, where the Cotter fails in shear. Cotter fails in shear. In other shear failures, see, we will see the formula here. This 7th number formula. It is d2 into a. Okay, d2 into a into tau. What about this? In this case, is there any shear stress of Cotter involved? So we have already done the analysis that this sigma t of Cotter is not involved because Cotter never fails in tension. See, what is sigma t? Tensile stress. So this Cotter is never pulled like this. Can you see this Cotter? क्या हम Cotter को अभी ऊपर से और नीचे से ऐसे खींच रहे कभी या फिर मैं ऐसे रखता हूँ? Do we ever pull the Cotter like this? No. So unless and until we pull the Cotter like this, it will never fail in tension. So in the entire design or in the entire this socket and spigot Cotter joint, we never pull the Cotter like this or like this. एक ही बात है orientation अलग किया मैंने. So we never pull it. So there is no question of Cotter failing in tension. So this sigma t for Cotter will never be used. Now talking about tau. Tau is what? Tau is the shear stress. Shear stress for which material? Shear stress for this material. Okay, there we have two material. This is one material, socket and spigot. This is another material, Cotter. Now we have two values of shear stress. So which shear stress we will consider? So if you eliminate the shear stresses for this, at remaining places we will use this shear stress value. Okay. So how will we eliminate? So if you look at the formulas, wherever shear stress is involved, only those formulas we have to consider. So which are the formulas where shear stress is involved? Shear stress is involved from formula number 7 to 10. Tau, 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 tau. So out of which we have considered that here it is exclusive failure of Cotter. Exclusively it is failure of Cotter in shear. So we have to use this tau for Cotter only. Tau for Cotter only. So I think this is also clear to all of you. Okay. Now at three other places, that is in formula number 7, 9 and 10. In formula number 7, 9 and 10 also we have tau, tau and tau. So we'll first think about formula number 10. So see, in this formula number 10, that is thickness of socket spigot collar, thickness of spigot collar, it is this. So where from it shears off? It shears off from the spigot. It shears off from the spigot. And how we get a ring shaped structure. As I have already explained to you, we get a ring shaped structure something like this. So if it is here and it fails here like this in the shaded portion. So is there any quarter involved in this? Quarter है क्या यहाँ पे? Quarter तो आसपास भी नहीं है, quarter तो यहाँ पर है. So how this failure will happen because of quarter? No, there is no question of quarter. There is no question of quarter creating shear failure. So in this case, we will use which tau? We will use socket and spigot wala tau. Socket and spigot wala tau. Now we will analyze this formula. Formula number 7. Formula number 7. How this failure occurs? This failure occurs in shear. Now see, it is like this. It happens in shear. Okay. It is failure of what? It is failure of quarter, or it is failure of this spigot? It is failure of this spigot. It is not the failure of quarter. Formula number 7 talks about failure of what? Failure of spigot. Okay. मतलब spigot fail होगा, spigot fail होगा. ठीक है, ये slot निकल के आ जाएगा बाहर. What is going to fail? This is going to fail. So किसका स्ट्रेंथ कंसिडर करना पड़ेगा? आप इसका स्ट्रेंथ कंसिडर करना पड़ेगा या इसका स्ट्रेंथ कंसिडर करना पड़ेगा? वी हैव टू कंसिडर द स्ट्रेंथ ऑफ स्पिगॉट. फेल कौन होने वाला है? स्पिगॉट. फेल कौन होने वाला है? स्पिगॉट. I will give you with an example. Okay, I will give it. I explain with an example. Suppose the shear stress of this is 90. Okay, I am taking random value 90, 90, and shear stress of this is 100. Okay. Now, what is going to fail? This is going to fail. This is going to fail. So this D2 and A, you can see this dimension D2 and A. ये किसका dimension है? इसका dimension है. इसका dimension है 90 का, जिसका shear stress 90 है. तो इसका shear stress 100 रहने दो, 150 रहने दो या 500 रहने दो. ये तो टूटने वाला है कितने पे? 90 पे. ये तो 90 पे टूटने वाला है. अगर मैं इसको 90 पे टूटने वाला, if this is going to fail at 90, whatever may be the shear stress of this, it is going to fail at 90. So at what value should I design it? I should design it at a value of 90 because I don't want this to fail. I don't want this to fail. मुझे ये fail नहीं होना है. ये fail हो गया तो इसका यहाँ पे कुछ relation ही नहीं है. इसका यहाँ पे कुछ relation नहीं है किसका? Cotter का. This should not fail. So कौन से वैल्यू पे ये फेल होता है? It fails at 90. So we are not concerned with the shear stress of Cotter here. So here also I will write tau for what is it? Socket and spigot. Okay, where is the cursor? Socket and spigot. Now if you have understood this, that in this case, we are not concerned with the strength of this because we are not concerned with the failure of this Cotter. We are concerned with the failure of this spigot. So since we are concerned with failure of spigot, we are interested in the strength of this. If you are running a race, there are two students, say A and B. A has more energy, B has less energy. So who will fail? B. A का एनर्जी कितना भी ज़्यादा होने दो, B फेल होगा उसके एनर्जी लेवल पर. B A के एनर्जी लेवल पे फेल नहीं हो सकता है. B has to do nothing with the energy level of A. Same is the case with this. And so if you have understood this, this is the similar case. Okay, this is the similar case. Clear? So here also we'll consider what? Here also we'll consider socket and spigot. So as far as tau is concerned, there is only one formula where we'll use this tau for Cotter. So this tau will be used for only one formula, only one formula. Now we are talking about sigma c. Okay. Now we'll understand for sigma c. कभी sigma c के लिए use करेंगे. Now we'll analyze one by one again. We'll start with formula number 3. All of you can see this formula number 3. It is d2 into t into sigma c. d2 into t into sigma c. Okay. Crushing will happen. Crushing will happen of what? Crushing, now see, there are two variables. One is d2 and another is t. T is for this and d2 is for this. d2 spigot के लिए, t quarter के लिए. Correct. Now when I'm pulling this, okay, when I'm applying force like this, when I apply force like this, what will happen? What will happen? Now I am not thinking about any other failure. I am thinking about the crushing failure only. बाकी सबको बाजू में रखते हैं. उसका हम उस जगह पे will take care of that formula. Here we are considered only with the crushing failure. Crushing देखो किसका हो रहा है? Crushing इस quarter का यहाँ पे हो रहा है. किसके साथ हो रहा है? इसके spigot के साथ. This inner portion of spigot. So क्या क्या क्रश हो सकता है? ये भी क्रश हो सकता है, ये भी क्रश हो सकता है. both can be subject to crushing. This one as well as this one. तो हमको किसका क्रशिंग करना है? किसी का नहीं. हमको क्रशिंग किसी का नहीं करना है. We don't want any of this to fail. We don't want any of this to fail. I will give the numeric values now. I will give the numeric values. Sigma c of this is say 7070. Sigma c of this is 7070. Sigma c of this is 100. Now what will happen if I take the sigma c of this as 70? अगर हम ये sigma c लेके solve करते हैं तो ये टूटेगा क्या? No, because sigma c of this is 70 and we are designing at 70. Will this fail in crushing? इसका sigma c तो 100 है. Will this fail in crushing?
No.
No. So all of you agree to this. So if you take sigma c as 70, which is the lesser than this, lesser in both the cases, then it will not fail. Now, if I consider sigma c as 100, will this fail? इसका sigma c कितना है? 100.
No sir.
ये तो फेल होगा नहीं क्योंकि उसका 100 ही है. इसका क्या होगा?
ये फेल होगा सर. 70 है.
70 पहुंच जाएगा तभी फेल हो जाएगा. हम तो 100 के लिए डिजाइन कर रहे हैं. 100 के लिए डिजाइन कर रहे हैं. हम ये लेवल पे डिजाइन कर रहे हैं, लेकिन ये तो नीचे ही फेल हो जाएगा. 70 पे फेल हो जाएगा. मतलब कौन सा सिग्मा सी लेना है यहाँ पर? मिनिमम. सो आई विल राइट हियर सिग्मा सी मिनिमम. मिनिमम ऑफ सॉकेट, स्पिगॉट और कॉटर. दोनों में से जो मिनिमम रहेगा वो लेंगे. नाउ कमिंग टू दिस फॉर्मूला नंबर 5. फॉर्मूला नंबर 5 एंड 6 इतने बचा है ना, 5 एंड 6. अभी 5 एंड 6 में से 5 नंबर का जो फॉर्मूला है दैट इज व्हाट? डायमीटर ऑफ स्पिगॉट कॉलर. कैसे मिलता है वो? ये देखो ऐसे मिलता है ना. क्रशिंग हो रहा है ना. कभी क्रशिंग हो रहा है जब कॉम्प्रेसिव फोर्स एक्ट हो रहा है. कॉम्प्रेसिव फोर्स एक्ट हो रहा है. अब मैं इसको खींच रहा हूँ. खींचूंगा तो क्या होगा? इसका और इसका कांटेक्ट आएगा क्या? विल देयर बी एनी कांटेक्ट बिटवीन सॉकेट कॉलर एंड स्पिगॉट कॉलर इफ इट इज पुल्ड? नो, it will try to separate from one another. But the moment I apply compressive force, what will happen? There will be contact of socket collar as well as spigot collar. Okay. यहाँ पे cotter है क्या? Is there cotter in picture here?
No sir.
Sorry. Cotter is not in picture. So there is no concern of cotter. So what will we write here? Sigma c of socket and spigot. Socket and spigot. I hope this is clear to all of you. And next is, again there is one more crushing failure happening here. Crushing failure happening here between cotter and now I am referring to formula number 6. I am referring to formula number 6. It is the failure of socket collar. Sorry, it is failure of socket collar in crushing. So where it is happening? It is happening, see where? Can you see this small portion, this portion, this मतलब ये D1 है और ये D4 है. So D1 और D4 के बीच में का पोर्शन और D2, एक्चुअली D2 और D4 के बीच का पोर्शन, एक्चुअली D2 और D4 के बीच का ये इतना पोर्शन और सेम नीचे का पोर्शन, उतना पोर्शन इसके साथ क्रशिंग होगा यहाँ पर और यहाँ पर. वेयर? हियर एंड हियर. सो दैट वे वी गेट दैट फॉर्मूला. सो अभी जैसे मैंने एक्सप्लेन किया फॉर फॉर्मूला नंबर 3, हियर आल्सो विल कंसीडर व्हाट? मिनिमम ऑफ सॉकेट एंड स्पिगॉट. मिनिमम सिग्मा सी ऑफ सॉकेट एंड स्पिगॉट. So I will write minimum of the value, minimum of सॉकेट्स भी गॉट और क्वार्टर, जो भी मिनिमम रहेगा वो कंसिडर करेंगे, क्योंकि मैक्सिमम वाला कंसिडर किया तो दूसरा टूट जाएगा पहले. ओके, दिस इज द एनालिसिस पार्ट ऑफ दिस. पहला सब जो हमने देखा वो न्यूमेरिकल हो गया. अभी न्यूमेरिकल सबको सॉल्व करते आता है. यू विल नॉट गेट एनी बेटर अंडरस्टैंडिंग ऑफ दिस फ्रॉम एनी अदर सोर्स. All of you now know that if the yield stress of material is given, then suitable factor of safety we have to select. But while selecting, we have to select which factor, how we have to select. We have to select less value of factor of safety for quarter and more for the socket and spigot. अब ये पे एक एग्जांपल एक्सप्लेन किया. अभी लाइफ में कोई भी एग्जांपल जब भी तुमको आएगा, so you have to, your thought process should be like this, that if you have to select different values of factor of safety for different parts, then which part is the weakest, which part should be weakest part, the one which can be easily replaced, one which can be easily manufactured, the one is of low cost. All this factor you have to consider while selecting the least value of factor of safety. ये हमने देखा था factor of safety में. ठीक है. And which stress you will consider? You will never consider the ultimate tensile stress. You will always consider the yield stress. You will always consider the yield stress, because this is ductile material. Okay, water material is here, used here is ductile material. So I am not going to solve this sum for you. You now know how to solve this, and I want each one of you to solve this in your book, and each one of you to write this. Wherever you have already written the formulas, so you can write these things, extra things which I have explained to you now in this. Okay, now another question. I am saying that the Cotter joint is designed for which load? Reversible load. Okay, I will write it here. So we are designing it for what? We are designing it for reversible load. Reversible load matlab reversible load. Reversible load matlab sometimes it is tensile and sometimes it is compressive. Now we'll come to magnitude. Suppose a Cotter joint is subjected to 25 kilonewton compressive force and 30 kilonewton tensile force or load. Design the joint if SYT is equal to 300 Newton per mm square.